Today we are talking about what is called the second derivative test. Very similar to the first derivative test, yes, they have a lot in common. Okay. All right. Yesterday, on the formula quiz, I asked you to write on the back of the formula quiz a paragraph about the steps that are involved in finding relative extrema with the first derivative test. Do you remember that? Yes. Okay. The second derivative test is another method for finding relative extrema. It is, in some instances, easier than the first derivative test. Some instances, it's harder. Okay? So, for the worksheet that you're going to do today, you have to use the second derivative test. There's no way, it says you have to. But on the AP exam, for example, they'll let you use whichever way you like better. So, you need to be exposed to both so that you can understand how it works. So, let's review real quickly. It's been a couple days since we did this. Second derivative tells us blank. What does it tell us? Concavity of f. It tells us the concavity of a function. Okay? So I want to review real quickly because the concavity is the key for knowing whether it's a max or a min. Okay? So if f double prime is positive, that means that f is concave what? When f double prime is positive, f is concave up. Exactly. And you need to know that for today. F double prime is negative. That means that f is concave down. Okay? So, we're going to do a little bit of an exploration here, a guided exploration. I would like you to draw what a concave up piece of graph looks like. Just draw it. What does concave up look like? And then glance at your neighbors and see if you get the same answer. Okay. Concave up is like a what? A cup. So concave up looks like that. Agreed? Okay. Before I go any farther, how do you find critical points? What do? You take the derivative and you set it equal to 0, and you find where the derivative fails. Okay? So, where on that piece of concave up graph does the derivative either equal 0 or fail? Right here. Agreed? So, that's the only critical point on that graph, correct? So, if I know where the critical point is, and I know the graph is concave up, I am guaranteed that that critical point is a relative what? Minimum. So, if this is the critical point right here, then it has to be a relative minimum because the graph is concave up. Does that make sense to everybody? Okay, now draw a piece of graph that's concave down for me. Where is the critical point on this graph? Where does the derivative equal 0? Up there, agreed? Isn't that where the critical point would be? So if you have a critical point on a graph and you know that it is concave down there, what does the critical point have to be? It has to be a relative maximum. So the concavity of a graph can tell you whether a critical point is a max or a min. Okay? That's the gist of how you do this. So let me write a quick summary statement to show you what we're doing with this. It makes a lot more sense in an example, and we'll do an example in just a minute. So the summary of this is, if f prime equals 0 or fails, and f double prime is positive, f has a relative what? Okay. Which one of these two scenarios, let's call this one A and this one B, fits this sentence? It has a point where the derivative equals 0 and the second derivative is positive. Which picture has a second derivative that's positive? A or B? A does. Second derivative is positive is concave up, right? That's picture A. So we know that it's going to have a relative minimum. So, if the first equals 0, that means it's a critical point. If the second derivative is positive, that means it's concave up, so that critical point must be a minimum. So, if f prime equals 0 or fails, and f double prime is negative, then f has a relative maximum. That is scenario B. F prime equals 0, that's a critical point. F double prime is negative, that's concave down. Critical point concave down have to be maxes. Okay. For some people, this is messing with your head because you see a negative here and you say the word max here. You would think that a negative means a min, but not in terms of concavity. Negative means concave down, and concave down means a maximum. Okay? So, this is what you need to take away from today. You need to know that if the second derivative is positive, it's going to be a min. If the second derivative is negative, it's going to be a maximum. Okay? So, let's do an example about this. F of x equals x cubed minus 3x plus 7. We're going to find the relative extrema using the second derivative test. That's the directions. I want to leave the summary in the picture because that's what we're going to use to do this. X cubed minus 3x plus 7. Find the relative extrema using the second derivative test. Okay. First thing we're going to do is find the critical points. We have to find the critical points first. How do we do that? We've been asking that question all morning. How do you find critical points? Derivative equals 0. All right, let's take the derivative of that. Derivative of x cubed is 3x squared minus, okay, and we're supposed to set it equal to 0. All right, what do? Solve for x. How do I solve for x? Add 3. You can move the 3 over. 3x squared equals 3. So x squared equals 1. Square root both sides. Whoops. Here we go. X equals plus or minus 1. Thank you for those of you who said plus or minus 1. Okay. Those are both critical points. Okay. Then we test where the derivative, if at all, fails. Does this derivative fail? No. Because no x is in the denominator of the derivative. Okay. All right. So everything we've done up to this point is exactly what you do for the first derivative test, isn't it? Isn't this what we do for the first derivative test? Now, if I had said use the first derivative test, what would be the next thing you do? You would do the number line, wouldn't you? But now we're going down the second derivative test road. We're doing something different. And that different thing is we're taking the second derivative. We're not doing a number line. So go back to the first derivative and take its derivative. What is the second derivative going to be? 6x, okay? You do not set it equal to 0. I actually made a mistake last period and did that for the second example, and I confused my kids. I'm not going to do it this time. Okay, we want to find the concavities. So what we're going to do is we're going to plug each one individually into the second derivative. We're going to plug the critical points, and I'm going to write this down, plug the critical points into f double prime. You plug them in because they are x values. And then we examine what their concavity is going to be. When I plug -1 into the second derivative, what answer do I get? I get -6, which is less than 0. Agreed? Because I got a negative second derivative, what concavity does that mean? It means, wait, no, what kind of concavity does it mean? Concave down. Draw a little picture. Okay? Now, new symbology for this year. 3 dots in a triangle. What does that mean? Therefore. Some of you have seen it before, some of you may not have. So therefore, there is a relative what? Max at x equals -1. That is your quote-unquote sentence that you need to write. That's all you need to put. You don't have to write the since f prime changes from positive to negative, blah, blah, blah. That's it. It's a shorter version. All right? Now, do the same thing with 1. When you plug 1 into the second derivative, what do you get? I get 6, which is positive. Which means what kind of concavity? Up. So draw a concave up. Therefore, there is a relative min this time at x equals +1.
So say the derivative fails, does that mean there's another critical point?
Correct. So if the derivative failed, I would have a third point I'd have to plug into the second derivative. Very good. That's very true. Yes, sir?
Can you write it like that, or does it have to be written out as points instead of x values?
It depends on what the question asks for. If the question says find the points of the relative extrema, then you would have to write it out as a point. Otherwise, you can just write the x values. Yes, sir?
If you did have to find the point, where would you plug the x values?
Very good question. If I had to find the point, where would I go back to plug the question? Always go to the original to find points. Always. Okay? Any questions? All right, let's do one more. We have time. So I'm going to go to a new sheet of paper. Is everybody done writing here?
Do one where there's a derivative at the bottom.
Actually, I'm going to do one with an E in it because we need to have some more practice with the E's. Okay? So, next example. F of x equals x e to the x. Same directions. Find the relative extrema using the second derivative test. Okay, what's the first thing I'm supposed to do? Take the derivative. Do I need to think about any rules in this case? I have to do product rule this time. I know you can do this. So right now, at your table, do this problem with product rule. Do the first step only. And then we're going to come back together and check it. Yes. I didn't tell you guys what it is. It is a big, fat, giant formula quiz. It's your final exam in this class is a glorified formula quiz, a giant formula quiz.
Are you serious?
This semester. The one you have to take. Okay?
The semester exam
is a giant formula quiz, yes. Yeah, seriously. Okay. Have you taken the derivative? This is what it should be. I'm just writing. Look up here and see if you got what I got. Are we good with that? Okay. What are we supposed to do with this derivative again? Set it equal to 0. Okay. How do I set that equal to 0? Take out an e to the x. Always look for greatest common factor. If you don't know where to go, that's your first step every time. So that leaves me with x plus 1 equals 0. Agreed? Okay. We need to set each one of these equal to 0. A few days ago, I gave you the big secret about e to the x. Can e to the x ever equal 0? No. Mark it out. It will never equal 0. So my critical point in this instance is -1 for where the derivative equals 0. You must check to see if the derivative fails. The answer is no, because e to the x never fails. X plus 1 is a line, it never fails. So the answer is no. Okay? We're doing the second derivative test. We don't do a number line. We go to the second derivative. Now, which line of the derivative should I take the derivative of? It doesn't matter. I think the factored one is easier. So very carefully take the derivative of this factored line where my finger is pointing. So, do I have to do product rule again?
Yes.
I have to do product rule again. They're side by side, so you do product rule. So 1 is e to the x, d2 is 1, plus 2 is x plus 1. What is d1? E to the x. Okay. Now, are we supposed to set this equal to 0? No. I do need to clean it up a little bit, though. So this will be e to the x plus, I'm going to go ahead and distribute backwards into this parentheses. So that'd be x e to the x plus another e to the x. Do you agree with me? So I have x e to the x plus how many e to the x's? 2 e to the x. It's easier to plug in the values if it's factored. So what can I factor out of that? E to the x, leaving me with x plus 2. Agreed? Okay. You're going to want to set it equal to 0 so bad, at least once when you do this homework. Do not do that. So we want to do f double prime of our only critical point, -1. We're going to do this without a calculator. So we have e to the -1 plus 2. Okay. When something has a negative exponent, where does it go? To the bottom. So -1 plus 2 is 1 over e to the first. Agreed? Isn't that what that is? Is that a positive or a negative number? This is positive. E is about 2.7. You could round it to 3 to kind of estimate. 1/3, that's definitely a positive number. I don't need to know exactly what it is. I just need to know that it's positive. So the fact that this is positive in the second derivative tells me that the graph of f is what? Concave up. So is -1 a max or min? A min. Therefore, there is a relative min at x equals -1. And I am done. Any questions?